Okay, in number 1 through 4, we're going to find the mean value, amplitude, period, and phase shift. It is important to remember that if we have a sine or a cosine function, y equals a times the sine of b times x minus c plus d, that the mean value is the shift in the y value, so that's the d value. And so our mean value here is 4. And the amplitude is the absolute value of a. So here's our a value. Its absolute value is 3 because amplitude is always a positive number. Period is 360 divided by the b value. So 360 divided by 5 is 72 degrees. And our phase shift is the c value. The number being subtracted from x is negative 20 degrees. So that means it's a phase shift 20 degrees to the left. All right, similarly in number 2, the mean value is the middle y value, which has been in the parent function is 0. When we translate this function down 5, our mean value will now be negative 5. The amplitude is the absolute value of a. That's going to be 2. The period is 360 divided by the b value. So 360 divided by 1/3 is the same as 360 times 3, which is 1080 degrees. And our phase shift is the number being subtracted from x, or the c value, so that's going to be 10 degrees to the right. In number 3, the mean value is the translation vertically, so that's 2. The amplitude is the absolute value of a. A is negative 1, so the amplitude is positive 1. The period is 360 divided by the b value, so that's the same as 360 times 4/3. That's 120 times 4 is 480 degrees. Phase shift is 0 because I don't see anything being subtracted from the x on the inside. Okay, let's rewrite number 4 in a form that will look more familiar. So negative 4 times the sine of, and inside the function we're going to factor out that 1/3. 1/3 times x plus 18 degrees. Check that by distributing. 1/3 times 18 is 6, and then plus a negative 1. That will help if you rewrite that in the more familiar form, and the inside of the sine function must be factored. So our mean value here is 1. The amplitude is the absolute value of a, so that's the absolute value of negative 4 is positive 4. The period is 360 degrees divided by the b value, so that's 360 times 3 is 1080. And the phase shift is the number that's being subtracted from x on the inside of the parentheses, which is negative 18 degrees, or 18 degrees to the left. All right, so for numbers 5 through 8, we're going to graph in the given grid, and we're going to include 5 points for each cycle from beginning to end. So, suggestion, let's use a new origin approach. The new origin takes into account the translations horizontally and vertically. Horizontally, we have a translation left 30 degrees, and vertically, we have a translation up 3. That means that we're going to relocate our origin at negative 30, comma, 3. If you want to think of these as new x and y axes, you can. And then I'm going to graph a related function that takes those translations out. So I'm going to graph y equals 2 times the sine of x. So we have an x value, we input it, take its sign, and then multiply it by 2 to get the y value of that related function where we've taken the translations out of it. So our inputs for the sine function are the quadrantal angles. And then we need to know their sine values. Sine starts at 0, goes up to 1, back down to 0, back down to negative 1, and back up to 0, multiply these by 2, and that'll give us our y values in relation to the new origin. So the first point, 0, 0, that's on the new origin, and then go right 90 degrees from there and up 2, right 90 degrees from there to 180 and up 0, another 90 over and 2 down, and another 90 over, and we're back at 0. And by 0, I mean on the new x-axis. So there's one cycle. We can repeat the same cycle. To graph the rest of this function. And then we can do the same in reverse. Just count carefully. 90 to the left, 90 to the left, 90 to the left, and 90 to the left. And now we've got the rest of the graph in that given grid. In number 6, you may want to rewrite this first as -4 times the cosine of 1/2 times x plus 1. So our new origin approach, the new origin is 0, 1, because I don't have a phase shift or a horizontal translation, but I do have a vertical translation. So that means our new x-axis is up 1, and our new y-axis is where the old y-axis was. Now I'm going to graph the related function, which is y equals -4 times the cosine of 1/2 times x. And input our x values, take 1/2 of those x values, take their cosines, and then multiply that number by 4, and that'll give us our y values for the related function. Inputs and outputs for the cosine are 1/2 x and cosine of 1/2 x. So 1/2 x represents the angles we're going to take the cosine of, and the cosines go in the next column, 1, 0, -1, 0, and 1. To get the column to the right, or the last column on the right, we're going to multiply those by -4. And to get the column on the left, we're going to undo the times 1/2. So we're going to multiply by 2. And now we just graph x versus y for the related function from the new origin. So the first point is at 0, -4. That's 4 units down from the new origin. 180, 0. And then over another 180 and up 4, over another 180 and back to 0, over another 180 and down 4 from that new x-axis. So there's one cycle. And then we can continue that same pattern on the left side. For number 7, if we use the new origin approach, you may want to rewrite this as y is equal to sine of 3 times x minus 90 plus 2. And then we can see that the new origin will be at 90, 2. So we're translating right to 90 and up 2. So I'm going to draw that new x and y axis in. So over 90 and up 2, and we can treat that as a new x and y axes, and then graph our related function that takes the translations out of it, which is sine of 3x. So all the addition and subtraction is now gone. So x, we multiply those x values by 3 and then take their sines. So the inputs and outputs for the sine function are the second and third columns. Here are our angles. And here are their signs, 0, 1, 0, -1, and 0. If you have 3x and you want to get x, we need to divide by 3. And now we can just graph those points from that new origin. So 0, 0 is on that new origin. So now from there, we're going to go over 30 and up 1, over another 30 and back down to 0, over another 30 and down 1, over another 30 and back to 0. So one cycle, and then graph many more cycles on the right side and several more on the left. For number 8, we need to address the inside of the cosine function and rewrite y equals 4 times the cosine of, now factor, 2 times x plus 30 degrees. So what that means is that our new origin is at the point -30 degrees, comma, 0. So we don't see a translation outside of the cosine function or a translation up or down, so our new origin is just to the left of the old origin. So I'm going to take and mark that off, 30 to the left of the origin and 0 up. So there's our new x and y axes. Let's graph our related function that takes the translation out of it. So that would be y equals 4 times the cosine of 2x. If I make a table of values, x, 2x, the cosine of 2x, and then lastly 4 times the cosine of 2x. So the angles and their cosines are in the 2x and the cosine of 2x columns. So 0, 90, 180, 270, 360, and their cosines are 1, 0, -1, 0, and 1. Multiply them by 4 to get that last column. And if we have 2x and we want the value of x, divide by 2. So now we just need to graph those points. 0, 4 would be 4 units above the new origin. 45, 0 is 45 degrees to the right and 0 up. 90 degrees to the right of the new origin and 4 down. And 135. To the right, or we're going by 45 degree increments here, and then 180 to the right of that new origin and 4 up. So here's one cycle. Several additional cycles to the right and several more to the left. In 9 through 11, we're writing an equation for each sinusoidal function. So I would encourage you to find that new origin first. So we're finding the exact middle vertically. So that would be our new x-axis for sure, because that's halfway between the top value of 3 and the bottom value of -5. Now, where we locate the new y-axis is something that can be done differently if you think of this differently. So what I'm going to do is I'm going to put my new y-axis right here, and the reason that I'm doing that is that's at a peak, and at a peak that would be the start of a cosine function. That peak is very easy to locate. Now, so what does that mean? My new origin is the point 30 degrees, comma, -1. So that would be my C value and my D value. From here, I have to recognize that one cycle starting at that point goes from peak to peak, so that would be a cosine function. So I know some things already. I know it's a cosine. I know that C and D are 30 degrees and -1. Next, I need to find maybe the amplitude. The amplitude, remember, is that vertical distance from the middle y value up to the top value. That distance right there is 4, so it looks like our a value is 4. And then lastly, we need to find that b value, and the b value is probably the more complex one to find. So from here to here, the length of one full period is from 30 degrees to 150 degrees, so that's a total of 120 degrees horizontally. And I know that 360 degrees divided by b is equal to the length of the period. So multiplying both sides by b and then dividing by 120, b must be 3. So I can write the equation as y equals 4 times the cosine of 3 times x minus 30 degrees, close out the parentheses and the brackets, minus 1. Now let's take a look at 10. For 10, one of the very first things I'm going to do is locate that new origin. I'm going to decide here that this ought to be a cosine graph. Whether this is a cosine or not, our middle y value is right here, so that means our new origin has a y value of 3. And then if I decide that this is going to be a cosine value, or a cosine graph, I can make this my new y-axis, so that we're starting our cycle at a peak. And so that is 60 degrees to the left, or our c value is negative 60. So there's our c and d. And remember, a is the absolute value of a is the amplitude. So our amplitude is 2, and this graph is right side up, meaning that our cosine is going to go from peak to peak. So our a value is a positive value, a is equal to 2. And then lastly, we need to measure the length of the period. So the period starts at negative 60 degrees and ends at, it looks like, 660 degrees. So the period has a value of 660 minus negative 60, or 720. And I do know that 360 divided by b is equal to the length of the period. So 360 is equal to 720 times b, and if we divide by 720, b will be 1/2. 360 divided by 1/2 is the same thing as 360 divided by 2. Alright, so now I have all those values, and I can write the equation. Y is equal to 2 times the cosine of 1/2 times x plus 60, so it's x minus the phase shift, plus 3. For number 11, I need to find where that middle value is, and the middle value is, the middle y value is 1, halfway in between our peak at 4 and our valley at negative 2. And so we know that the new origin has a y-coordinate 1. And now if we are going to choose a cosine which starts at a peak, then this will be our new y-axis, which is 270 degrees to the right. Okay, so the next thing we need to find is that amplitude, and the amplitude is the length of that peak, or the distance of the peak above the middle value, which is 3. So our amplitude is 3. And if this cosine function is going peak to peak, then our a value is a positive number. And then b value is the hardest one to figure out. In order to find that, we have to find the period. And the period is the length of the cycle peak to peak. Well, I don't see two peaks on here, so I'm going to have to be a little clever about this, and I'm going to measure the distance from one of the valleys to the peak. That distance is a total of 540 degrees, which means that the period is double that, so the period is 1080. So 360 divided by b is equal to 1080, and so that means that 360 is equal to 1080 times b. Dividing both sides by 1080, we get 360 over 1080, which gives us a b value of 1/3. All right, writing the equation from here, y is equal to a value 3 times the cosine of the b value 1/3 times parentheses x minus 270, our phase shift, close out the parentheses and the brackets, plus 1. In number 12, we're asked which equation represents the graph below. And so I see here a function a sinusoidal function that's been translated either left or right. It's not been translated up or down because our middle value on the sinusoid is still right at 0. What that means is the addition subtraction needs to happen on the inside of the parentheses. So let's eliminate those first 4 answer choices. Next, let's decide what makes sense to work with this as a sine or a cosine. So we are talking about a phase shift of either minus 30 or positive 30. So if we have a phase shift of negative 30, that would mean that the cycle starts right here at negative 30. That's neither a peak, nor a valley, nor a middle, so that cannot be right. So that means that these choices are out. Now we're left with a phase shift of positive 30 and deciding whether this is a cosine or a sine. So if I treat this as a phase shift of positive 30, there's our new y-axis, and then look at the graph from there. Here's one cycle, which starts at the new origin and then goes up to 1, back down to 0, down to negative 1, and back to 0. That is a sine function, so this must be the correct answer. In number 13, which equation represents the graph below? So this is a sinusoidal function that's been translated. If I can find that middle y value first, and then if I look at my answer choices, I don't see any phase shift or horizontal shift indicated in those, so I'm going to keep the y-axis in the same place. So from here, what I'm going to notice is that my amplitude of this function is 2, and my vertical shift is 1. If I graph from that new origin, let's go over that in red instead. That looks like the graph of a cosine function which goes peak to peak. So this is a cosine function with an amplitude of 2. It is right side up. It's not an inverted cosine. There's an inverted cosine. So if it's right side up, then that 2 is a positive coefficient in the equation, and there's a translation up 1, so a plus 1 on the outside. That's going to be choice F. Number 14 gives us 6 answer choices, and we're looking for the one that doesn't represent the graph. So this will be a little bit more difficult. All right, so if we were looking at choice A here, that would be an inverted cosine function with an amplitude of 2 and a phase shift of negative 150. So let's take a look at that and let's see if we can extend our graph a little bit backwards here. So I'm going to draw in some extra boxes here. And we probably need a couple. So each of those are 30-degree increments. So if I go backwards here to negative 150, then the graph would start right here and go to here. So negative 150 to positive 210 is a 360 period. So that one is an inverted cosine function starting at x equals negative 150. So that one is actually valid. So I'm going to uncircle that one because that one actually works. All right, let's take a look at the other answer choices. So now the next answer choice, y equals 2 times the cosine of x minus 30. So this would be a phase shift of 30. So our new x-axis would be, or a new y-axis would be at x equals 30. And from here, the positive 2 indicates a right side up cosine function from that point. That also looks like that could be a cosine function. It's going from peak to peak. So if it's peak to peak, it's going to be a positive cosine function. If it's going from valley to valley, it'd be a negative cosine function. So that one looks valid. I'm going to check that one off of our list. And then let's take a look at the next one. The next one has a phase shift of 120. So 120 would be right here. And if I graph from 120, here's what one cycle looks like. That actually looks like an inverted sine function. And if it's inverted, our a value is negative, so that one's a check. All right, let's check out D. For D, we have a 210-degree phase shift. So that would be right here. And from that 210-degree phase shift, if we graph one cycle, we're going to go valley to valley. That's a negative cosine. So that one works too. Now let's take a look at E. E has a phase shift of negative 30. So that would be back here. And if we draw one full cycle from that moment, it actually looks like it's starting not really quite in the middle. And so that would be one full cycle. And that's neither a sine nor a cosine shape from that point. So this looks like it's our answer choice. Let's just check the last one. So the last one would be a phase shift of negative 60, which means that we're starting our cycle here. And if we graph one full cycle from that, that looks like a right side up sine function. So that one checks too. So the correct answer choice, which one does not represent the graph, is E.